Let's start this sunbeam drawing assignment together. On your screen, you see a sheet of information for critical sun angles. And you notice that I have chosen to work with Harrisburg, Pennsylvania. We know that it's approximately 40 degrees north latitude. And we also know that it's climate region number 3. All right, remember over here, we analyzed that a couple of weeks ago. In this section over here, I have pasted our sunbeam diagram, all right? And you can get that from the Appendix F, the SunPath models that I gave you earlier, or there are many of these located online as well. So let's slide down. And next, this table here is asking you for a lot of those sunbeam data, right? For December 21st, right, the winter solstice, and June 21st, the summer solstice. We're asking for different times of day and the altitude and azimuth. Now, the easiest way to do this is with that solar calculator that I just showed you. Let's take a look. Here we are interested in December 21st at 8 a.m. So I have entered that data here, and I have slid down and found the azimuth and elevation. You can absolutely round these numbers. We don't need that much accuracy for this particular assignment, right? And the tricky thing to know is that they are in a different order, right? So azimuth is the first number, and elevation or altitude is the second number, right? And they are measuring the azimuth differently than the diagram that I showed you before. All right, so let's just make a note of that. Coming back to this assignment, you can see that the altitude we just found, they called it elevation, was 5 degrees, and the azimuth was 126. I put this note just for me to remember that that 126 is going to be measured clockwise from true north. There's a couple more pieces of information on this page. One is this building type, whether it's envelope dominated or internally dominated. This is the difference between are most of your heating and cooling loads coming from the envelope of the building or coming from what happens inside. Most small and even medium-sized buildings are envelope dominated. You only get to internally dominated buildings when you're much larger, and talking about skyscrapers, etc. Right? So that's why I've circled the envelope for you. And there's down here we have a date for the last day of the underheated period and the overheated period. Now this is climate data, so let's pop back to our climate region and turn to the second page, and let's look at this section right here. Once I've zoomed in, all right, you can see that we kind of have a diagram of our year. We have the comfortable period, okay, kind of these spring and fall shoulders. We have a section of the year that is too hot, right here in the summer, and a section that is too cold. Well, that's actually quite a bit of the year, all right, on that side. So the question is last day of the underheated period, all right, that's going to be our too cold, right? And if you slide along the year, the last day is, let's call that May 21st, right? And then last day of the overheated period, all right, too hot section, let's call that August 21st. All right, I'll leave the rest of this table up to you as the student to continue. Let's take a look at the sunbeam diagrams on the next page. Here's an example for exercise number 1. It says for a building at 36 degrees north latitude, draw the sunbeam on the plan and section for February 21st at 9 a.m. So the first thing we want to know is the altitude and azimuth. We're going to go over to that solar calculator and find out. And there, somebody has already done this, all right, for us. The altitude is 27 degrees. The azimuth is 51 degrees east of south. Now, just so you know, this is written differently than the solar calculator gives you, all right? So let's scroll down here and see. All right. First, let's look at the plan, and we're interested in what kind of angle the sun comes in the windows. All right. What do we need to look at? Is it altitude or azimuth? It's azimuth. So we're interested in this number, 51 degrees east of south, and you can find it right here. Here is south. 51 degrees east of south is this angle. All right. And we would come in these windows. Right. By the way, the last sheet of this packet is a printable protractor. All right, so if you are sketching these by hand and need a protractor, you can go ahead and use that one. All right. Next, let's take a look at this section. All right, we're interested in the altitude, which is shown up here as 27 degrees. All right, that's 27 degrees up from the horizontal. All right, so we measure that and we find our sunbeam coming in. All right, here we see another of the exact same exercise, only we've chosen a different latitude. So step 1 is to use that solar calculator to find the altitude and azimuth. All right. Step 2 is to use the azimuth, all right, to find where do the sunbeams penetrate this building, and to find the altitude and figure out where the sunbeams penetrate this section. Exercise 2 is much the same, so let's take a look at exercise 3. In this case, we've chosen multiple important dates and times to kind of expand our analysis, and that's why there's a bunch of different color-coded sunbeams shown on this one. So for a building at 36 degrees north latitude, draw the sunbeams on plan and sections below, and we've got 3 different date and times. The first thing to do is to go use that solar calculator and find the altitude and azimuth for each of those date and times. Then you will come down here and start with the plan, all right? And we know with the plan that we're interested in the azimuth angles, right? And so you can diagram them right here on this plan. And then take a look at the section. There are 2 sections, all right? This one is cutting east-west, all right? And so we can really see that June morning sun is coming in. This one is cutting north-south. I thought that was a little confusing, but it's cutting this direction, all right? And so we can see right here, all right, that we've got some December and July sunbeams coming in. So all these sunbeam exercises have led up to this point, analyzing the sunbeams for your project. All right, and there's 2 parts to this. The first one is with no shading device at all. All right, and so you are first going to select what critical or important dates and times you'd like to study. All right, write them in here. All right, and find your altitude and azimuth for those dates and times. All right, come on down here. Now this drawing is showing a north, south, east, and west window, all right, and a skylight. All right, so take a black pen or something and just black out any of the ones that you're not doing. All right, and for example, if you were assigned the east window, all right, north, south, east, you would leave this window on the plan, all right, and black out the other ones. That's why there's so many on here, all right. And so you would then analyze the sunbeams that might come into your window, all all right? And you'd do it over here as well on this section, right? You can ignore the other ones. You can black out all of the others. Once you've done that, all right, remember that that was with no shading device. We're going to slide down here and complete the same exercise, only this time your shading device is in the way, all right? And hopefully we'll see a big difference. So use the same dates and times, same altitude and azimuth, all right? Also, use the black pen and color out in all the windows except for the one that you were assigned, all right? And you're going to sketch in your shading device design. It looks like this, all right? If you were the east window, you're going to draw something, whatever it was that you designed over here in plan, and you're going to draw the same thing, all right, whatever it was that you designed in section, right? Do your best with the scale. This is not, I mean, it is proportional, but it's not drawn to a particular architectural scale, all right? So go ahead and use these little people as your guide. Once you've done that, now you can cast your sunbeams again, and we should see quite a few of them blocked by the summer sunbeams, all right? Sorry, let me say that again. We should see the summer sunbeams being blocked and hopefully the winter sunbeams being let through. Thanks, everyone.